So, hypothesis testing. It is something we're going to be doing the rest of the semester. So we have to get a few terms under control. We have to get the ideas, procedures under control. And we just have to get through it. Okay? So we have to get this first chapter 8 down. This is going to give us 4 hypothesis tests. Chapter 9 will give us 4 more. And then we're going to get a total of 11 that we use and you will be tested on, plus a few others that come up in other areas. So we have to be able to identify them, and then we have to be able to do them. So the whole idea of a hypothesis test is a way to formally make a statistical decision. And when you make a decision, you weigh outcomes. Okay, should I do this? Should I do that? Should I take this highway or should I go this route? You're always making a decision, and it's based on a probability or your instinct of where are you going to be the most successful, where is you're going to have the least likely bad outcomes. So you use probability, and we use probability too, and in this case it's called the p-value. And the p-value is going to represent the probability of seeing an outcome that far from what you think it should be or further. And that sounds a little weird right now, but it'll make sense hopefully in a second. So I heard on a video the other day, this person was target shooting, and they grabbed 10 rounds of a certain kind of 22 ammunition. They had a bucket full of it, and they had 2 duds out of 10 rounds. And that kind of just perked up my ears because I'm thinking, well, okay, so random sample? I mean, you just grab 10 rounds, so I can take that as random out of a bucket. But that seems pretty high. 2 out of 10, that's 20%. So I thought, well, if I was going to do a quick little statistical study of this, I'd probably select a bigger sample. In this case, I'm going to hypothetically grab 100 rounds, and I test fire them all. And if I find 15 were duds, in other words, they didn't fire, does that give me good evidence that the percent of duds is greater than 10%? Now, again, I'm just making some of these numbers up. This is hypothetical. If a company is manufacturing ammunition and 10% or more is bad, they're not going to be in business very long. But I'm trying to give you an idea. So formally, we have to state what we're testing. And that's H naught, P is equal to 0.1, or HA, P is greater than 0.1. Now these hypotheses, we're going to have 4 different statistical tests, and 3 of them, well, there's going to be 3 different kinds of hypotheses for those. P for proportion, I could put mu for a 1 sample Z or 1 sample T, or I could have a sigma for a 1 sample chi-square. We're talking 15 out of 100, 10%. That's sounding pretty much like a proportion to me. Next thing, this HA, your book is going to use H1. I use HA, that is traditional. It stands for the alternative hypothesis. H naught stands for the normal or null hypothesis. It is what's accepted, but this is what you really believe. Okay, so before I started this study, I would write out what I believe is happening. I believe the proportion of defects is greater than 10%. All right? And I go and collected my samples, and I found out I had 15 out of 100. All right? Now, this symbol right there, greater than, well, that goes with this right here, because it's greater than 10%. If I would have said less than 10%, I would have flipped it the other way. If I would have said not 10%, I would have a not equals to. If it's an inequality like this, it's called a one-sided test. In this case, it's upper-tailed. If it was less than, it'd be a lower-tailed. If it was not equal to, we would call it a two-tailed. Now, I don't want you getting hung up on all this. I'm just saying those are terms you're going to hear, you're going to see. So based on my data, based on my hypotheses, I would calculate what's called a test statistic. So here's my test statistic, and I'm going to show you how I calculate it in StatCrunch. It's a Z because we could use the normal to approximate for the proportion. So don't get hung up on that. I just have to write it. I'm compelled. But it's 1.67. This is what I use to help get the p-value. And I'm now going to switch over to StatCrunch. I got 2 different things going on here. So let me hit the edit. So you're doing this in Chapter 7 for confidence intervals. You would just decide, okay, so 1 sample proportion. You went 1 sample, you went with summary. I put in 15 successes out of 100. But instead of doing a confidence interval, I'm going to do a hypothesis test. And right here, I have to change that to 0.1, and I have to change my alternative to greater than. So when I hit compute, it gives me a bunch of information. There's my test statistic, which in your homework you're going to be asked for. P-value, that's the real important thing. That's the probability of seeing this test stat, all right, if the null is true. So the probability that I see a sample proportion of 0.15, 15%, what I'm saying is 10%, is around 4.78% probability of occurring. Now, we use that to help make a decision. So the 1.67, if I put in, and I went 0.66, I put more numbers in here. I just want to show you how these two relate. If I put that in for my z on the standard normal, the shaded red area, since it's greater than, gives me that value, which you'll notice is the p-value. The area to the tail from that z is your p-value. The probability of seeing a value bigger than this, in this case, is 4.78. All right, these are terms that are going to come to you as we progress. P-value comes from the test stat. The test stat comes from hypotheses and your data or your summary statistics. All right, so p-value, 4.78, also from the software I just showed you how you can do it. I would expect you to just do it this way and get it. I just wanted to visually show you here. So we have to make a decision based on this p-value. And the smaller the p-value, and this is backwards kind of thinking, so bear with me. The smaller this p-value is, the more evidence against the null. And what I want you to think about is, what's the probability that I see this 15 over 100 if this is true? So if I take that sample and I get 0.15, the probability of that occurring is very small. The smaller that probability, the more evidence I have that my null is probably wrong. It's probably too small. So generally we have what's called an alpha or significance level. Significance is an unfortunate word, but we're stuck with it. It doesn't mean earth-shattering. It just is a terminology for what I'm about to say. This alpha level can be 1, 5, or 10. Flashback to confidence intervals for a second. 100 minus 10 is 90%. 100 minus 5 is 95. 100 minus 1 is 99. Okay. We use these to make a decision about our hypotheses. So I would pause me right now and write down what I have after this important. Just write that down. I have to tell you an alpha. If I don't, use 5%. Okay, and sometimes I won't on tests. So if I don't tell you, alpha is 5%. Otherwise, the problem will say the significance level is this. Okay, that's the alpha. If your p-value is less than or equal to that alpha, you're going to reject the null. All right, so if the p-value is small, smaller than, in this case, 5%, we're going to reject that null. If it's greater than that 5%, you're going to fail to reject. So these are like cutoffs. Okay, you're going to pick that cutoff and you're going to decide, all right, if I'm less than that, I reject because I have evidence. If it's greater than that, I fail to reject. So what we would typically do, I take my p-value we found, compare it to 5%. That's my p-value is less than alpha. We're going to reject null in favor of the alternative. This is traditional wording. So when I say I reject a null in favor of the alternative, I'm not saying the null H0 is wrong. I'm just saying we have evidence to support the alternative. HA appears to be correct. So it's really important that you get all this weaving together, and MyMathLab is going to kind of force you. When you reject, that means you have a small p-value. The p-value is less than alpha. If you reject, that's saying that you have evidence. If you reject, we're saying it is significant. So rejecting, having evidence against the null, and being significant all mean the same thing. So in this case, I rejected, and I'm going to reject the null, and that means I have evidence that the alternative is true, which means I have evidence that the number of duds, or percent of duds, keep putting a number in there, is greater than 10%. So I know this is a little overwhelming. I've done this a lot of times. Okay, you're going to get through it, but it's a process. So I would go back through this, look at the other videos I posted, and start on that homework. The main thing I need you to remember is that the p-value is less than alpha, you're going to reject the null. That's what you have to hold on to. All right, talk to you later.